doing a curl. Sorry, first I'm showing you how to deploy. Deploy is one line. Firebase deploy only functions hello one. And then deployment takes 30, 60 seconds, depends how lucky you are with their machines warming up. And then you get an endpoint back, which is that one, the second orange highlight. And from that point, you go to your Firebase console, and you can see that function being deployed and running for you there. This one already has been there, so it's got some statistics of how many times it was executed, what is the average time for it to run. And then you do a CURL, you get content length 7. I did it on purpose, so because there's 7 lines of code, and I wanted it to return something that's got seven characters. You go to a web browser, hit the URL, you get the hello one back. So what's going on in here? Super simple. The only thing you need to do, this is fully, so if you take this code and send it to, deploy it to Firebase, to Cloud Functions, this is all you need. Of course, you need packages.json, you need some project setup for it to go. But with this code, what we do, we import dependency of Firebase functions. So this is what basically all the Firebase functions are about, where you can use their services. And we do it standard Node.js module export stuff, where we export only one function, now hello one. And then what we do, we subscribe to an event called HTTPS on request. So anything that is HTTP on request, let's return, so response.send hello one, just go with hello one. So we're gonna deal with put, we're gonna support put, get, post, whatever we're doing, we're just sending it back. This is very simple. Right, so now let's add course. So we wanna make sure it's gonna work in our web app. Again, I just only, the stuff in color is the things that changed that I added. We require another dependency called course. There is a very neat way in Node.js where you can require it and straight away initialize it. So what I'm doing is requiring course. It's an NPM dependency, initializing, saying we're going to support origin, and then I'm just wrapping my arrow function with another function that again is an arrow function sending hello to back. Simple as that. Request response gets added to course. Request response, course does the job for me to doing all the headers, and I do a hello to. Here's the output. Again, deploy, same deployment method, just hello2, different function name, get an endpoint. Now we've got 2 functions. We run it, and you can see here we've got access, control, allow, origin, test.com, because I'm doing a curl with origin, HTTP, test.com, and we've got the content length 7, hello2. Right, and finally, right, so just for you to get back here, I'm going to show you this again. What they do with Cloud Functions, they're actually using Express in the back. So you could go here and you could actually use vanilla Node.js with Express and do a standard hookup with Express to whatever you want to do, get post. You could change the headers, whatever you want to do. Here I'm just showing you kind of a simplified version. When you as an engineer, you don't need to really modify headers, do anything. You're just caring about handling the request, getting someone trying to get something out, and you want to send it back. But if you want to go deep and kind of play with the low-level stuff, you can do it. They don't restrict you. Right, and the last one, sorry. And now we're gonna now allow our endpoint to accept a query parameter, and we're gonna return some JSON because all the apps want JSON these days. So here we go, 1 line of code. So the only thing that changed is rather than sending text back, I'm just wrapping whatever I'm sending back in curly braces. So I'm returning JSON. I didn't do anything else. And then I'm saying in my message, I have my request.query.text. So the parameter we're going to accept for this function is called text, and I'm going to show it to you over here. So again, very quickly deploy. We've got it running. So now we've got 3 functions running, and on the bottom you see in Chrome, I'm saying hello free, question mark text equals world, and I'm getting back a JSON message, hello world. That's our parameter. That's it, job done. And this was it's pretty awesome. Sorry for my GIF, but I wanted to play it for you. So me being in Java for so many years, and kind of before Java being C and C++ world, and playing a bit of Python, it's actually pretty cool. I think that the reason I switched to Node.js and JavaScript, and especially Firebase, is the speed to the market, and this is what I care about the most. For me as an engineer, I kind of stopped caring about writing everything from scratch myself and making sure the authentication works, because at Google they've got 100 people doing the security and I'm just one guy. So even if I think that I know better, I probably don't. And what I now concentrate on is I want to build an app and get it out there as fast as possible, and this platform allows it for you. So the differences are the Firebase is going to be a bit more expensive for you than if you want to do it yourself, or a bit more expensive than GCP. But the advantages is that you launch your product, when it's going to scale and you're going to have a lot of users, you're going to worry about your billing costs then. I always say that first launch a product, get your first million users, and then you can rewrite the whole thing again, because that's what startups do. Right, now we're going to do something useful with the Firebase Cloud Functions. We're going to call a third-party API from the function. We're going to call a weather service and check what's the weather like in Warsaw. Actually, in this case, it's Barcelona, where I'm based. We're going to check the weather in Barcelona, and we're going to write the result back to two databases. In this simple example, we're just going to call the API. That's it. So the gray stuff is the code you've already seen. We require the function, we require the course. We add another import, another library called request promise native. So this allows me to send an HTTP request to whatever I want in 4 lines of code. Here, I added the word async because I'm going to use an await keyword here to wait for my request.get to return the result before I go to the next line of execution. And what we do here is we're calling this beautiful openweathermap.org API endpoint weather query. We're passing a city name, so we want to check weather for a city. And then app ID is the kind of API token that they have. And do you see, guys, what I'm doing here? I'm saying functions.config openweathermap.key. So I'm not exposing in my code any secrets, and that's what the Firebase platform and Cloud Functions, they allow you to do it through the config environment they've got. What it means, it's kind of a JSON file to which before your deployment, you have a script that you can write to it, and you can store their passwords, secrets, whatever you want, logins, tokens, and they will never be exposed in the code, but always accessible in your code that you deploy with your for your account through functions.config. So openweathermap.key is a custom key I defined for the config where I could store the key for the openweathermap. And when I'm saying it in my request, I want a JSON back. And what's happening here, I'm getting it back, and straight away I'm sending it with status 200, and I'm sending the result back to whoever requested this from me. And this is, again, deploying is 1 line. We got it running now, so now we've got 4 functions. And here you can see me in Chrome calling that endpoint with a city Barcelona, and I get my status 200 that I just, let's go back quickly. The status 200, which is defined here, and I've got my result, which is basically the result I'm just proxying back to whoever called this for me. And that's it. So let's go back. So with these few lines of code, we just managed now to call a third-party API, get the data back. We requested as JSON. We're passing the JSON back, and we're using this one is at the moment going to be, this is JavaScript ES 2016 because async await is here. Let's go here. Okay, now let's only allow GET requests in our code. So what we want to say is we're not going to allow post, put, get, post, put options or delete. We're just going to make sure anyone who's calling our endpoint is doing a GET. And again, 3 lines of code with a curly brace. Request method doesn't equal GET, return status 405. Request method not supported. And here we go. We deploy, and I'm doing a CRL with -x parameter post, and I'm getting back the JSON that you see in status 405, error request method not supported. That's it. Right. And finally, we're now going to do something that's very powerful, and this is where I think Firebase makes your life easier when working with data and databases. We're now going to save that result we got from the maps, from the weather API to 2 databases. Right, here we go. 2 lines of code on the bottom. We require another dependency. Firebase require Firebase admin. We need that dependency to initialize our connection to a database through a 1-liner initialize app command that takes, you've seen already, functions.config Firebase. Again, you don't define that config. It's defined for you because the environment knows your app ID. It knows the databases. It knows you. It knows your security. So it just initializes that. That's it. I initialized connections to the databases. And on the bottom, now just the result I got. It's a 1-liner because I wanted to fit it in a screen. You could probably wrap it in more lines. But what we're doing here is we're saying here, again, I'm using await. So first, I'm going to save it to .database. That's the real-time database from Firebase. That's the big JSON tree that's super fast. And then the other one is Firebase.firestore. Is their new product called Firestore, which is kind of a MongoDB. So you've got collections of documents. You've got documents more structured. It's better for more complex data. So what we do, database.ref, it's the reference, or basically it's where I want to store the data. We've got weather/request query city. So we're going to have a collection of weather report for a city, and we're going to save it in the results. And I'm doing a push, so I'm doing .push results. So I'm sending that result I got from the fetch straight away to a database with a push. Push command in real-time database generates a key for me. So basically, it assigns a unique key for that result, and I'll show it to you in the data and store it for me. And Firestore, I wanted to show you two databases so you can see differences in the syntax, and you can see how quickly you can use them. Firestore, same kind of a story. We've got collection, we've got a weather collection, we've got a document. This is our query parameter city. We've got a collection of results, and we're going to use a command method called add, and we're going to add the result to it. Again, it generates a key for me. So here we go. Two databases. Those are screenshots from my console, which I'm going to show you later live. We've got on the left real-time database. We've got a weather, Barcelona results. The generated unique key. I didn't need to do anything, and that's our result saved. And on the right, I've got the Firestore, same result saved basically into a different database. And kind of that's it. So I cheer you to that. And I think it was pretty fast. I don't know if you guys agree. Okay, now what we're going to do is I'm going to do more complex stuff. So I'm going to go back. Check my time. Awesome. Let's write a Cloud Function to go by a database event. So what Cloud Functions are, I didn't mention it before because I want to kind of get into it gradually. Cloud Functions allow you to respond to any type of Firebase events, to any of the events that they have, to any of their products. So what you can do with Cloud Functions, you can listen to anything that happens to a database, new data store, data deleted from Firestore real-time database. HTTP request that I showed you, so there is an HTTP trigger, someone's trying to send you a HTTP request, you respond to that. They've got a storage, so if any file is saved to Firebase storage, which is kind of an S3 bucket in AWS, you get an event back, file deleted, file created, and then you've got a standard pops up, you've got analytics events, you've got new user sign up event, user deleted account events. There's a lot of events you can subscribe. I'm going to show you here only database events. Again, same code, gray stuff is the stuff you've seen, and now we're going to look at the new things we've changed. So I'm going to play with it. I'm going to add timestamp, and I'm going to show what's happening. So what I'm doing here is they have a built-in timestamp constant for real-time database and Firestore. What that means is that if you would send your, let's say, time now from your client, before it gets to a server, it's not time now anymore. It's time minus the latency, minus someone hacking your timestamp or anything. So what they built in is that you can pass this constant to as a value of your any attribute you want, and then they're going to use the server time now to basically timestamp that attribute for you. So again, we've got two things happening in here. There are two actually functions here: database weather city created and Firestore weather city created. Again, what I'm doing here is I'm showing how you can now deal with events to two databases at the same time, so you can pick which one you want to work with. But then I can answer you some questions of what are the actual difference of the database. Super simple. The first one is functions.database reference on create. So whenever there is a weather, curly braces city created, which means it's kind of a wildcard, any kind of a city, any ID created. On create, I'm going to get an event from the function. And what I'm going to do is I'm going to do event data reference. So that's the reference, the path I'm working with. So weather city. Update. So I'm going to update that data with a timestamp called created. That's it. And the bottom one, same story, but Firestore. Functions.firestore document, weather city. Again, curly braces means wildcard. We don't care what city it is. On create event, let's add a timestamp there, and let's use merge true, which means if data already exists, I want to merge it rather than override it. It's an important thing. And here's the result. So that's the same data. I'm going to show it to you. I want to run through the presentation. I'm going to show you to you live demo of how it works. But what happened here is the same Barcelona result we got. But what happened is when it was created, my Cloud Function figured out I added a result called Barcelona and added for me this created timestamp, which is in this case a long. And on the right side, there's nothing. And this is where the differences come with real-time database and Firestore. In Firestore, Barcelona as a document doesn't exist. The only thing that exists, it's a collection called results. Because when I was adding the result to Barcelona, I didn't create explicitly Barcelona as a document. So it doesn't exist at this stage. And I'll show you how we're going to fix it later. There are basically two ways. Either in your client, before you're going to save that result, to the results collection, you need to explicitly say Barcelona new document. Here we go, we're gonna have this document ready. Or you're gonna do it on a backend whenever there's something written to one of the sub-collections. So what's happening here, it's good that they did it this way, because I don't really, maybe there are cases where I don't want the documents to exist. I want this path to be there because my path is whether Barcelona results some ID and I've got my results there. Maybe I don't want it to exist, but if you want it to exist, you need to explicitly create it. Firebase real-time database is different because it's just basically a big JSON file. Every path is always created for you. And we've got Snoop Dogg showing me some good moves here. Right, and then we're gonna implement the counter. So what we're gonna do here is anytime we add a result to a database, we wanna keep track of how many results we've got. So how many weather results we've got in real-time database and Firestore. This is gonna get a bit more complicated, but I hope it's not gonna be too boring. I'm gonna keep it light, and then I'm gonna move to the live demo, so I'll show you how things are actually changing in the database and everywhere. Right, same code you've seen. We only need two dependencies. We need the Firebase admin dependency of Firebase functions, and now we've got two events we're subscribing to. Database weather result count increment and Firestore weather result count increment. And again, same kind of a concept of subscribing to an event. Functions.database, my big reference. A lot of wildcards. We've got weather/city wildcard, so I don't care what city it is, London, Barcelona, whatever someone put in there. Results, and there's some, and again, key for the result, I don't care about it, on create event. And then what I'm doing here is I'm using a built-in transactions that they've got. So I'm gonna read the count that's already there. If it doesn't exist, I'm gonna assume it's a 0 and add a 1 to it. And then this one-liner here, at the same time, is reading my attribute count, incrementing it, and saving it back. One-liner, that's it. So I just increment, every time there is a new result, we're gonna increment it by 1. Firestore is more complicated because we need to do a few more tricks here. What we do here, they've got a wrapper. So you wrap your transaction around anything you want, any reads and writes you want to do inside it. The rule is first you do your reads, then you do your writes. You shouldn't do a write, then a read. So first I'm going to read some data using await. I'm going to check out what my city is. So I'm saying city, await, transaction, get. I'm getting the city objects. I want to see if there is a count in there, if it actually exists. And then I'm going to check. There is a one-liner here. It's a beautiful one. Some people don't like it. But I needed to make it compact. You could use if statements. So I'm checking, city exists. Okay, it doesn't. Assume it's a 0. If city exists, city data.count. So I'm actually reading the count from there. If count it doesn't exist as an attribute, assume 0 plus 1 transaction set. We're writing it back. This is an example of count decrement. And I'm going to be switching between two slides so you can see a bit of a difference in the code. So for the real-time database, we've got a few more lines, because here what we need to do is, before we're going to decrement the count in the real-time database, we want to check, we want to read the city object. So we want to check if it exists. Because the funny thing about a real-time database in Cloud Functions is that you can end up in an infinity loop if you would write your code in a way where you don't check things with Cloud Functions. So if I wouldn't have the city exist here, anytime a result would be deleted, because I'm using on delete event, I would decrement the counter, which is fine, right? That's a pretty, it's normal logic. So we could have it this way, like this one line. This is the same one-liner. I would, rather than doing +1, I would do -1, and the event would be on delete. But this is the problem here, that what happens if I actually delete the city? If I delete Barcelona with all its data, that would trigger this event because I'm also deleting the result and recreate for me my city with count equal to 0. So I'm trying to protect here and check that if someone actually deleted, if city doesn't exist anymore, so not someone deleted the result, they actually deleted the whole city, the whole thing with all its children, we don't want to decrement it because it doesn't exist anymore. So this is the check we're doing to make sure that the city actually exists before we want to write it back. And Firestore, same logic. Again, we're running it inside a transaction. We need to get the city, check if it exists, decrement it, and we're going to set it back to whatever it was. And the last one, this is called count guard, and I'm going to show it to you in action in a sec. What happens here is I'm trying to protect myself from someone deleting the count attribute. So what happens is, again, it's an event where in the real-time database, I'm subscribing to an attribute called count on delete, which means if someone in my data model, for some reason in a city deletes the count attribute, I'm going to recreate it back automatically. And you're going to see it in action in a sec. So this is, again, same logic that we had, very similar to what we had for the decrement. But the difference for real-time database is that when it's deleted, I wanna, rather than decrementing something, I can't decrement something that was deleted. I'm reading city.child results, number of children. So I wanna check how many results there are. Well, number of children, write it back as a count. And Firestore is a bit more complex, but again, and it doesn't, here's the difference. Real-time database allows you to subscribe on attribute level, so you don't subscribe to a document. So you can actually listen. Let's say you've got an object called user and there's a first name. What you can do with real-time database, you can only say, give me all the events when the first name changes. With Firestore, you can't do it. You can say, give me all the events when the user object changes, the whole thing. So here I've got a bit more logic of this if statement. The city on update, so the whole city object's changed. I can't subscribe to an attribute called count. I'm checking with an if statement if what changed in the city is my count attribute. So I'm checking previous.data count. If it wasn't undefined, so it means it existed before and now it doesn't exist, which means someone just deleted the count attribute from that object. And now I'm reinstantiating it back. I'm putting back the number based on the number of results, and that's it. Right, here we go. Here's the count that I'm going to show you in a second in action live demo. I'm going to try to do it. Usually it doesn't work. Live demos are hard, but we're going to try. Count 5, we've got 5 results here. Count 5 in the Firestore, we've got 5 results in our results collection. And here's your billion-dollar idea, maybe. And then, sorry, I'm going to show you this for a sec. So let's go and see it in action. Right, so here are all my functions that I've deployed that I showed you. Hello 1, hello 2, hello 3, weather. Here are all my events and triggers for the database, the Firestore, and real-time database. As I told you, deploying is just, if I would do this, and we would go here. Let's quickly show you how we deploy one line. Right. Hopefully if the connection is good, this should deploy. So this is a deploy command one-liner. I'm deploying hello 1 again. It's doing all the necessary checks for you. You don't write any deployment scripts, anything. You don't need to do any of that. And it just goes there and deploys it for you. It's going to be done in probably 30 seconds. And in the meantime, let's go back and show you stuff. So here's my real-time database, which is empty right now. And here's my Firestore, which is empty right now. Let's call our weather service and check some weather for Warsaw. Right, we got a result bug, that's our JSON. Let's go back here. Oh, we've got the weather, got Warsaw, got count 1, got created, we got results, and let's delete counter. Boom, I deleted it. See what's gonna happen. Oh, it's back. I can't delete it. Let's delete it again. Delete it, boom, it's back. Right, let's delete the whole weather thing. Got nothing in the database. Go here. I'm going to refresh it quickly, go back here to show you what's happening. Boom, integrated count 1 is back, and created timestamp was added for me on the fly. Let's change the city so you can see something different. Barcelona. Because the functions are so fast, I'm trying to show you. Yeah, already it did for. But basically on the fly, the function added the timestamp, created increment and count to 1. If we're going to go here and hit Barcelona again. Now we've got count 2, we've got 2 results. Let's delete 1 result. Removed. Our count is decremented to 1. Let's delete all the results. Boom, our count is decremented to a 0. Right, this was real-time database, and this is Firestore. Here we go. So I've got weather, Barcelona, and Warsaw. These 2 were added for me because we called them. Barcelona got town 2 created. We've got our results. We're gonna go to results. Let's delete 1 result, this one. The document, start delete, we're deleting it, and then our count will decrement to 1. The UI takes a while. That happens instantly. Their average time for like function execution 50 milliseconds to 100, depends on how good your code is. So the thing that you really need to be careful with when writing Cloud Functions is optimizing your code. So you can write it in an hour, but then you can spend 5 days making sure, if it's a big function, to make sure that you're not wasting too many resources, that you don't have infinity loops, and that your function is not, consuming too much time. So count 1, let's delete all the results. Delete, oh sorry, I want to delete results, I want to delete this collection. Boom. So actually delete the Barcelona, it's gone. Let's go again here. Call it Barcelona's back. Results are back, count is back. Let's delete the count from Firestore. Deleted it. Boom, and it will be back in a second. Count 1. Let's call this thing again. We have a result. Count is 2. Let's call the endpoint again. We've got count 3. Let's delete the count. It's gone, and it's back. So this whole stuff was just handled by those few lines of code I showed you in Cloud Functions. These two databases are super easy to get started with, super easy to use. Obviously, both of them are real-time. So out of the box, what they offer to you is that you can subscribe in your client, let's say iOS app, Android app, or your web app, or your Node.js backend, to any of these data being changed real-time. Like in Cloud Functions, I was subscribing to an event. You can start your web client and subscribe to, you can say, anytime Barcelona data changes, let me know in my JavaScript. Let's say it's a web app and I want to do something. They give it to you out of the box, but you don't need to use that. You can use these two databases as normal databases. So you can save to them, read from them, and delete from them like you would do from MySQL without the real-time aspect to it. Real-time aspect is nice if you're building, let's say, a chat application. Let's say you're tracking stock on a stock exchange, or you're doing something that needs that real-time aspect of it. It's out of the box, and the client code will be one line of code. The function is called .on, so which means on any changes to any path, the reference you define, you'll get notifications back. Right. Finally, I've got a extra question. I'm offering beer to anyone who can tell me what F1 or F2 does, or I can offer you wine or coffee. First one to guess, I can take you for a lunch and we can have some wine. F1 or F2, anyone? This is basically ES 2006, JavaScript ES 2016, because I'm using includes, so that's why it's ES16. In general, it's actually ES6, so the old naming convention for JavaScript, which means ES 2015. I know it's confusing. But we've got two functions. F1 is doing something. It's using a lot of arrows and using a filter and includes. And there's an F2 that's doing some other magic. And I know there are no if statements, and I know it kind of looks a bit crazy, but that's what it is. There's a self-executing function in F2, and reduce, we don't have that. And there is actually an interesting thing happening in F2 as well. Anyone? Any ideas? F1 or F2? What are they doing actually? What is happening here? Anyone? Any volunteers? Wine, beer, coffee, sandwiches? I give hugs and kisses, but to those who want them, I don't know. Or we can go skateboarding. F1, F2, no one? Okay, it's fine. This is what they do. So F1, if we're going to give it these two arrays, it's going to return to us 2 and 4. So it's basically an intersection of arrays. So that code is doing for me an intersection. And the 3 dots A, it's an object, it's a parameter expand, which means I can pass as many as many variables to it as I want. So I could put here 5 arrays, 6 arrays, 7 arrays with different data in it, and we'll return 2 and 4. It actually not only works for arrays of numbers, it works for array of anything that will find for me an intersection. And you can pass in an array of objects or booleans or strings. And the second one is basically, it's flattening my object. I'm giving to F2 a nested JSON, which got an X, there is a Y, there is a Z, and Z is equal to 1, and it returns to me a flat object, which got one attribute X, Y, Z equal to 1. So it can flatten any type of object that contains arrays or even functions inside for you. It's very useful if you've been doing a lot of JavaScript work and you've got those nested JSON object, and then if you'd write all your if statements to check if X exists, then if Y exists, and if Z is there, let's read the value. So rather than doing that, we're going to flat it out and just check if XYZ exists. So for this, if we would have a user object that's got nested object inside, let's say you've got a profile. Inside the profile, you've got a first name and last name and address. It would flatten it for you, and you have, let's say, profile dot first name as a key to that JSON, and you could work with that. It's very useful when you work with on front ends and anything, just to flatten up. And then it's a very simple to write a function that unflattens it for you based d equals dot. That's my default value for d, which is a delimiter. This code is written in this way for a purpose. I wanted to obfuscate it a lot, so not to expose what C is or what D is, so you guys could guess what it does. But this is kind of the power of JavaScript, the latest JavaScript, where you can do things like this in a few lines of code. Right, so thank you. There's my GitHub. You can check that I've got a lot of examples on GitHub. I can show you some, because we still got time. I can show you a few examples of how you can quickly build a messaging app with Firebase as a client. I'll show it to you now. And how you can build a Notes app where you can take a simple Notes app using Firebase, and how you can test it with Chai, Mocha, Targaryen, which is a static test, rules analyzer, and end-to-end tests. And if you want to talk to me, drop me an email. If you want to learn more about Firebase or Node.js or JavaScript, you can find me on LinkedIn as well. If you want to grab a beer, me and my friend Terry here from a company called Whipper that we're doing now, it's a messaging app. We're going to be at a place called Tudanakiyu from 9 p.m. If you want to come and talk about tech or just talk about anything, just feel free to pop in. And I'll show you some examples, and then we can do some questions if you guys want. Right, so we've got this one and this one, and here we go. So this is a full-on repository on GitHub. If you'll get it, it gives you a full-on Notes app with authentication. I'll show it to you in action, and it tests it in 3 ways. These are the test results that I've written for database end-to-end, database static and memory analysis, which is super fast, and the test I think takes like so 57 tests passing in 175 milliseconds versus 36 milliseconds end-to-end tests. And then I did the same test for storage, so you can kind of have a look how you can test Firebase in different ways in different products. Deployment one-liner, and here is the demo. Let's change this to this. That, so my password is 123456 for everything, so if you want to hack to my Gmail, feel free. Right, Notes app. Let's start a new note. I'm going to say, hello, buy milk. We're going to go back. We've got our note here. We're going to come here. We're going to delete that. We've got some panel here. We're going to sign out. This is using Vue.js and AUF from Firebase. Firebase real-time database, and that's it. And then reset password is built in for you by Firebase. Signing in, signing out, different methods is built in. If we'll go here, this is their authentication thingy, where you can go and define what sign-in methods you support: phone, email, password, Google, Facebook, and anonymous. I know the question could pop out. You can also do custom. You don't need to deal with this. You can spin off your Node.js backend or whatever backend you want, return a JWT token, and you can authenticate against whatever system you've got. It doesn't matter. They don't show it to you here because it's custom. You kind of spin it up, and they just consume the token. You need to set up some security stuff, and it's going to work. So these were notes, and this is another project called Messages. A very simple chat/messaging app where, and I'll show it to you in action. Let's go to this way. Copy the URL, spin it off in here. Let's do this. Actually, let's kill that. Right, so we've got 2 windows. I'm going to say high in here, it goes high in there. Hello. So this is the real-time aspect for you taking care. If you look at the code, it's like probably like 3 lines of code where I can subscribe in these 2 places. If now I'll start Safari and do the same thing. Safari app, paste in. So you see it's a different browser. And I'm gonna say hello again. And I'm gonna send some emojis. And I'm gonna do a heart, love hearts. And here we go. This is the same, that's the real-time aspect for you out of the box to get you going very quickly. So you can check out those projects, you can fork them, and you can build on top of them. I think Nodes is more interesting because I just recently updated it to ES 2007, so JavaScript ES 2017. So you can look all the latest JavaScript stuff there. It uses a way to sync everywhere for all the tests. It uses a way to sync for the app. And it shows you how to really test your app end-to-end statically, which is the fastest way, and how to test storage from Firebase. We built with this an app called Whipper Live. I'll show it to you so you can see what stuff you can do with it. And I built with this app, echo.co.uk. So this application that supports, its NHS is a healthcare system in the UK. This app is built on Firebase. It's iOS and Android. We've got a pharmacy web app. It's all Firebase, all real-time aspects, all security. So you can build things like this. NHS is rigid. They want your stuff to be compliant with all the data protection stuff and security, whatever the naming is. I'm not an expert on security and DevOps stuff. But they approved Firebase to be used with NHS. And then we built this thing, Whipper. I'm not going to play you the demo, but Whipper is a messaging app like Viber or WhatsApp, but with a twist that you can be any character you want, let's say Batman, and on top of you just simply texting, you can send a superpower. Like you can send a bat, you can throw a bat, burn someone. So it adds to your chat a bit of a fun by using, you can be, a different character and do stuff. And again, that's totally built on top of Firebase. This one is using Firestore as a database, and the NHS one is using real-time database because we were dealing here with 1.5 terabyte of data from NHS, which contains, I think, 10 million medical items, which is all the drugs that they prescribe in hospitals and doctors prescribe, which can be refunded. What else it does? So yeah, it does a lot of data analysis. Obviously, the question will be, can real-time database support 1.5 terabyte? No. Well, it can, but it's going to be a bit tedious. But what Google does for you, it hooks up real-time database to BigQuery, which is kind of a schemaless MySQL thingy database. And that thing can process any type of data. You can stream to it directly. So what we did, we had a pipeline written that takes 1.5 terabyte of data from NHS with an XML, transforms it using RapidMiner to JSON, loads it to Firebase, and then streams it in chunks to the BigQuery for analysis and running all the stuff we need to do. And that's it. Whipper is basically a perfect candidate for Firebase because it's a chat app, it's real time, so we're using all their real time aspects out of the box straight away. So that was it. What else can I show you? I think that's it. Any questions, guys? Happy to answer any questions. Any challenging questions? Or any simple questions? There, no? So again, which one?
If I can define IP whitelist or blacklist to the API.
I can't answer that question because I never did that. You mean for the Cloud Functions? Yes. Well, you can read the header so you can lock it down in that way. But on that answer, I can't answer it to you because we never, the reason is I'm not sure if it's possible or not. So the answer is I don't know because we never done it. We didn't have a requirement like this. But as I told you, this is what I want to show you before we can finish. Google Cloud Platform. If I go to Google Cloud Platform now and go to their console, and console, and so here we go. I'm going to close everything. So Google Cloud Platform is like AWS. This is their competitor. If you could see here, I have my Firebase console here. And my project ID here is AF43D, whatever. And then I'm here in the cloud, in the Google Cloud, Google Cloud Platform is the same project. So what happens is, basically Firebase is a layer on top of GCP. for developers to make their life easier in terms of DevOps. Anything that I just did in Firebase, if I go here, let's say to the functions, which are here, Cloud Functions by GCP. This is the same as AWS Lambda, so this is the competitor for Lambda. And App Engine, their data store, is equivalent of DynamoDB at AWS. All my functions are here. And here you can do more stuff. You can go inside the function, more stuff than in Firebase. This is like where you can do the crazy DevOps stuff. You can trigger it, check out the source, run some testing on it, do an invocation, there's more stats on it, so it's all backed up. And the same story goes to the storage. As I told you, if I go to storage now, here we go, prototype AF3D AppSpot. So my real-time database is actually backed up by App Engine. And then the last thing I wanted to show you is Compute Engine, SQL Spanner, Compute Engine. Where was it? There was data store, I think. Oh, maybe this is the guy. But if I go here and I go to their storage product, and I'm going to take a screenshot quickly. Oopsie. And I'm going to upload that screenshot into here. So that's like an S3, right? This is S3 equivalent of GCP on AWS. I uploaded my screenshot, and then I go to GCP console, and I will see my screenshot here. So it's Firebase is like an abstraction layer on top of GCP, which is kind of like AWS, but less hassle than AWS anyway. If you've been doing a lot of AWS work with Elastic Beanstalk, EC2 instances, or DynamoDB on Lambda, and you'll switch to GCP, you'll see that they made your life as a deployment engineer much easier because you've got less pain configuring your stuff here. But if you really want to just build your app and deploy it, you go Firebase, which sits on top of GCP. So this is the advantage that you're getting from using Firebase. Pricing-wise, obviously Firebase is the most expensive product, but you only pay for the resources used, so it's kind of the cloud approach to things. But as I said, I wouldn't worry about it, because if you're going to scale and you have 100,000 users, then you're going to worry about your billing cost, because then you're going to have investors putting some money into you, and then you can rebuild it with whatever you want. You can even do it in C++, I guess, but maybe not. But or you can do it in Java or anything you want. But the reason we use it a lot, and I use it in a lot of projects, is the time to market. This is, for me, super important. The story I can tell you is like, when we built Echo, we built it in Java. It took us 6 months to launch the iOS app, Android app, the backend, the API, and the web app. And then we were managing that project, and we were changing a lot of things, and Java was super painful. Patching the database, all this stuff was crazy. Hibernate, crazy. And then we switched to Node.js initially with Firebase, and we rebuilt the whole thing in a month, and then it took us a month to migrate. So that's the time we kind of gained. But rebuilding was easier because we knew what we were rebuilding, right? When we built it first time, we were figuring out what are the features. It doesn't work, this works, you know. It's like every project, you can't really plan it. So rebuilding it took us a month, migration took us a month because it was an NHS platform. So migrating it was kind of super important. So we did like 10 rehearsals, migrating rehearsals before we pulled the trigger on the live one and actually did the proper one. So 10 times we went for the whole scenario of moving data, user accounts, everything we had, storage, uploaded files, uploaded proof that people are paying taxes. We had data like that. We did it 10 times before we moved to Firebase, but that's the advantage. But the bill is like, I think at Echo we had 50, when I left we had 50,000 active users. The bill was 500 euros per month for using Firebase. So with 50,000 paying, because Echo is a paid service, paying customers 500 euros a month for your hosting, I don't think is a lot, but some people can argue. But then I wouldn't worry about it. If it would be 50,000 euros a month, then you can probably think about writing it in something else and maybe moving to GCP and using their Kubernetes stuff that they've got to, you know, manage it better if you know what you're doing. But that's it. Any other questions? I mean, we've got like 5 more minutes, I guess. Anyone? Any questions? No questions? Okay. I'll be around after this all day. If you want to come and just chat one-on-one and ask some, you know, code questions or platform questions, just find me and I'm happy to answer any of them. Thank you very much, guys.